Compared to the mouse, reading keyboard events is quite simple. There's no motion and there's no double clicking. All you do is get the keystrokes one at a time. But then you have to figure out what key has been typed, and you do have things like the Control key and the Shift key that may be held down. To show you how this works, here is a canvas that responds to the keyboard. To receive the events from the keyboard, this example implements the key listener interface. If you understand how the mouse interface works, this one will look familiar. It's pretty much the same thing. Like the mouse program, this program has a list of string references that are to receive the information describing the keystroke. The paint method simply displays the strings in the window. These are the three methods that are called in the case of keystroke events. The key typed method is called whenever a key is pressed and released. The key pressed method is called whenever a key is pressed, and the key released method is called when a key is released. This means there are three method calls for every completed keystroke. Having three different method calls for this is no burden whatsoever to the computer because nothing is nearly as slow to a computer as the movement of a human finger. No matter how fast you type, there is still an enormous amount of time wasted between the keystrokes. The first thing being pulled out of the key event method is the key character. Some keys, such as the function keys and the shift key, don't have a character associated with them, so the character is the special value named undefined. Every key on the entire keyboard has its own unique number, called the key code. Even with keys with the same character, if the keys are different, the key code is different. For example, numeric keys usually exist across the top of the keyboard and on a numeric keyboard to the right. Now, two keys may have the same digit and display the same digit, but they will have different key code values. Some information is duplicated. The key location call returns you some information about the location of each key. And just like with the mouse event, the ID number tells you which of the three events generated this particular key event. The modifiers of a key are the other keys being held down. For example, the Alt and Control keys are modifiers for any of the character keys. Now, the modifier information itself comes in the key event object as a set of bits, and the method getModifiers returns you this set of bits as an integer. Passing this integer to the method getKeyModifiersText returns a string that lists all the modifiers. This method returns a Boolean value that is true only if this is an action key instead of a character key. This will be true for the function keys and other keys that are not associated with a character. And just like with the mouse, the param_string method returns a character string that fully describes the key and everything about it. And here's the window. Now, there's a thing known as focus. Only one window at a time has focus, and all keyboard events are directed to the window with focus. The window, when it first appears, may or may not have focus, so you may have to do whatever is necessary for the operating system to focus the window. In most cases, this is simply a matter of selecting the window with the mouse. Now, here you can see the results of keystrokes and the values that they produce. For example, the key for the digit 6 is the same in two locations. The key code is different, but the characters are the same. Now, holding down the Shift key and using the same two keys changes the character. If you want to get a feel for how this stuff works, you should play with the program and get a feel for it yourself. It's a matter of seeing the response to the keys that you press, and there's too much going on for you to see how it all works by me telling you which keys I hit and then you watching the numbers that change. Just give it a try.